number 7, determine the moment of inertia of the area shown in the figure with respect to its centroidal axis. With respect to its centroidal axis plural, no? So meaning we have to determine, no, the moment of inertia both for x sub o, or both with respect to x sub o and with respect to y sub o. So these are the centroidal axis, no, for this composite area. So we have here, it's just like an I-shape din, no, cross section, no, I-shape area. Okay, but as you can see here, class, this is not symmetrical vertically, right? This is not symmetrical vertically because as you can see here at the top, no, this part of this area, okay, this is much shorter, no, than the rectangle here at the bottom. So meaning its centroid will not just be somewhere here, no, because if the centroid is just somewhere here, class, no, if you draw an x-centroidal axis here, it will not be balanced. No, the area here below or above will not be balanced, no, with the area below, right? That's why, class, its centroid, the location of its centroid, more likely it will be located somewhere here, more likely. No, that's why it's actually drawn already here. It's already drawn here, as you can see. All right. So from here, it's already drawn here, no, the location of the x-centroidal axis. And for the y-centroidal axis, it's naman din, no, it will just be here, right, for the y-centroidal axis. So again, class, we're going to determine the moment of inertia with respect to this axis, no. So in this case, class, no, it's not seen here, no. The problem did not give us, no, the exact location of x sub o. No, I mean it did not give us the value of this y bar. So we have to determine first this y bar. So again, class, to determine this y bar, this is just the y coordinate, okay, of the centroid, okay, of this composite area. So we have to determine that first. So we're just going to apply, no, what we learned nga, no, in determining the centroid, no, of composite figure. So for this case, we will need to use our formula for determining the x or y coordinate of the centroid. So in this case, y coordinate, that's what we need here. So this will just be a times y bar equal to the summation of each area times their corresponding y coordinate, no? So the corresponding y coordinate, that will be the distance from the centroid of each area going to the let's say reference axis. So in this case, class, in determining the y bar, no, our reference axis here, class, will be here at the bottom, right? Because that's where you want to measure y bar, no, from the bottom. So again, class, in determining, no, the y bar, no, our reference axis here is here at the bottom, since this is where we are going to measure y bar, right? Ayan. Anyway, so from here, class, for the total, you can actually create a table here, class, no, wherein, let's say, you assign this as your area 1, and then here at the middle, this will be your area 2, and then here at the bottom, this will be your area 3. So you can make a table, but we can also directly input the solution here, no? Okay, so from here, class, for the total area, so we can just add the area 1, area 2, area 3. So for the area 1, sige, so let's write the area of this area 1. So the area of this area 1, this is just a rectangle. Okay, and the area of a rectangle is just base times height. Its base is 6 and its height is 1. So this will just be base is 6 and its height is 1. So this will be for the area 1. And then for the area 2, this will just be base times height also. Its base is 1 inch, right? And its height is 12 inch. So this will be plus base times height. Okay, and then lastly, for the third area, its base is 12 and its height is 1. So this will just be 12 times 1, right? So that will be the total area, no? So multiplied by y bar. So this will be equal to the summation of each area multiplied by their corresponding y coordinate, no, from the reference axis. So let's say we start from area 1. So for area 1, let me just so that I can show you the centroid, no, of the area 1. So this is our area 1. So obviously it's centroid, no, for this rectangle. It's just at the geometric center, right, of this rectangle, no, here at this point, no. So you have to determine that distance going to the reference axis. So in this case, our reference axis is the axis below, no, here at the base, no, of the composite area. So what will be this distance? This distance is actually 1 plus 12 and then half of 1. The half of 1 is this distance. What is the half of 1? That is 1/2 or 0.5, right? So meaning the y here for the first area. Okay, anyway, so let's write here also the area already. So for the area 1, its area is 6 times 1. So its corresponding y nga, as I've mentioned, sige, so siguro natin, we write their corresponding y here. So for the area 1, its y is 1 plus 12 plus 1/2. Is that right? Do you follow that? Plus the distance y. All right, that will just be 1 plus 12 plus 1/2. So what will be the answer for that? 1 plus 12, 13 plus 1/2, 13.5, right? So this will be multiplied by 13.5. Now for the area 2, for our area 2, so anyway, so for our y, for the y of area 1 class, this is measured naman above, no, above the reference axis, right? So it's positive. Now for the second area, our second area is what is the area of this area 2? This is base times height. So this will be 1 times 12. And what will be its corresponding y? So its corresponding y, no, for area 2, its centroid. Okay, let me rewrite that again. All right, so that I can show you the geometric center of the area 2. So the geometric center of area 2, let's say, is somewhere here. Okay, so we need the distance, all right, from that centroid going to the reference axis. So this is y sub 2. So your y sub 2 is just 1 and then half of 12, right? Do you follow that? 1 plus half of 12, because this distance, now from the centroid, okay, going here, this is half of 12, right? And then plus 1. Do you follow? 12 plus 2 over plus 1. Do you follow that? Your y for area 2. So this will be 12 plus 12 divided by 2 is actually 6 plus 1. That will be 7. Right? And this is also measured above the reference axis. No, so this is also positive. And then for the last area, for our area 3, no, its area is just, okay, its area is just base times height 12 times 1. And what will be its y? So the centroid of this area is somewhere here. Okay, so we just need this distance for y3. So your y3, this is just half of 1, right? Half of 1, half of 1. So this is just 1/2. Okay, so for this class, this is just multiplied by 1/2 or 0.5. So from here, you can already solve plus, no, for y bar. Plus, what's the answer for y bar here? All right, 5.7.
7.
What's the unit for this? All right, so this will be inches. Tama ba ito? 5.7 lang talaga, class, yung lumalabas din sa inyo? Wala nang kasunod yan? Okay. All right, sige. So, class, what we just determined here, class, is just the location of your x sub o, because we need this y bar, no? So from here, class, no, what we really need to solve here, class, is the moment of inertia with respect to the x centroidal axis. Okay, and y centroidal axis. So let's start with the moment of inertia with respect to the x centroidal axis. So for the moment of inertia with respect to the x centroidal axis. So we write this, no? So this is moment of inertia with respect to the x centroidal axis. So this is a composite figure. So we have to sum up, no, all the moment of inertia of each area, no? So if we need to add a transfer term here, we have to add a transfer term, no? So in this case, I think we have to apply, no, the transfer term for the three areas that we have here. So we have three areas here for this rectangle, and this rectangle. So let's start, no, by determining the moment of inertia of the first rectangle here with respect to the x sub o. So this time, class, our reference axis is here at x sub o. Okay? So we are already determining here the moment of inertia. So from here, okay, so the x-centroidal moment of inertia of a rectangle is just base time, bh cube over 12 rather. So its base, no, for area 1, the base is 6 and its height is 1. So this will be cube over 12. And then, class, I think we need to add here a transfer term because obviously the centroid of this area doesn't coincide with our reference axis x sub o, right? So we need to determine this distance. So let's say this is distance 1. Class, what is this distance 1? All right. So from here we can actually analyze, no, this distance 1, no? How can we determine this? So all right, sige. Can you tell me what will be this distance 1, class?
Ano po, 7.3 po.
Where do you get this? Can you explain where did you get this?
Ano po, nag-start po ako sa taas. 'Di ba yung center po ng ano, yung pangalawang composite figure po is
Ito,
6. Opo.
6.
Tapos
Ito.
opo, 6 yan.
Oh,
Tapos dinagdag ko po yung ano,
kalahati dito.
opo,
Tapos,
dinagdag yung kalahati diyan 6.5 tapos dagdag ng 0.3, 6.8 pala, sir. Tama
ano,
ba?
no?
Sana
Of class,
nagulan po saglit.
our distance 1 from the centroid of the area 1 going to the reference axis. In this case, your distance is just here.
Ay ano po,
Ano?
saglit.
Tingnan niyo mabuti, So kasi kapag nag-quiz kayo, talagang kayo ang aalam niyan.
Opo,
So wala tayong definite na
6.8.
formula para dyan.
6.8
6.8?
po.
How
Opo.
come? Paano nakuhang 6.8?
Kasi po, yung
6
sa
ito, 0.5 ito.
opo. Tapos yung
Oh,
sa reference point po natin kasi 5.7 po yun, right? So,
ito, 5.7.
opo, 0.3 na lang
Ah,
po yung missing.
ito.
Kaya dinagdag ko po yung 0.3.
Ah,
Yan po.
okay. Actually, that makes sense naman. Tama? That makes sense. Your y bar is 5.7. So, oh, no.
Yes, sir.
No, this 5.7 actually is from the bottom. Yung mini-measure mo na 6 is just, are you getting my point? This is, your 6 is just here. Sige, isa pa.
7.8 po, sir.
So mali yung 7.3. 7.8? How come? Ang gulo
Ano
mo ng
po?
drawing natin. Teka lang, burahin ko yung mga dapat burahin.
Yung distance po ng centroid ng shape
Wait lang. Ano kaya, i-drawing ko yung sinasabi mo para kayo nga mismo yung nag-a-analyze. Okay. Again?
Yung distance po ng shape 1 from the bottom line po.
Mula centroid na yon.
Apo, centroid po.
Okay. Mula centroid na yon. So, ito yon.
13.5?
Yung kanina yun no?
Yes po, 13.5.
Okay, so that is 13.5. And then?
Minus sa Y bar.
Y bar. Alright.
5.7 po.
Okay. So since there is no definite kasi dito class formula on how you're going to determine that distance. So ikaw mismo yung kumbaga mag-iisip, no? It is you yourself who will think how you can get that distance. So from here, so he measured from the bottom up to the centroid of the area 1 and then he just subtracted this y bar so that the distance he measured is this distance. So this is really the distance one, right? So that will be 13.5 minus your y bar. Your y bar is 5.7. This is, what is the answer for this class?
0.8.
7.8? Tama ba? Tama, 5.7. So 8. All right. So this is 7.8 inches. Ha? So this will be your distance one. All right. Anyway, so going back here, class, the area of the area 1, this is just 6 times 1. And then its distance nga is 7.8. Okay, so this should be squared, ha? All right, anyway, so next, no? So let's proceed, class, to the area 2. So for the area 2, okay, so similarly, it's just BH cube over 12, the centroidal moment of inertia of area 2. So its base is 1, and its height is 12. So 12 cube over 12. Plus, of course, you also need here the transfer term. So the area is actually 1 times 12, right? And the distance D, so for the distance D, this will be that distance. Now, the distance from the centroid of this area going to the reference axis. So what will be this distance?
1.3 po.
Where do you get
Squared.
that?
Yung 7 minus yung y bar po.
All right. So from the bottom kasi, class, no, going to the centroid of the area 2, right? So that is 7, right? And then we subtract here, class, your y bar. So 7 minus y bar. So that is 7 minus 5.7. Are you following, class? Yung iba? Baka hindi nakakasunod yung iba. Let me know. All right. So this is 1, ano ito? Sorry, 1.3?
Yes po,
Tama?
1.3 inches po.
Okay. So from here, so this is the distance, d sub 2. So this will be 1.3. And then this will be squared. So lastly, for the rectangle or the area 3, our base is 12 and our height is 1. So that will be BH cube over 12. So base is 12, height is 1 cube over 12. So we also need to include here the transfer term because the centroid of the area 3, no, there's a distance, no, going to the x sub o, the reference axis. So what will be this distance?
Ano po, sir? 5.7 minus 0.5 po.
5.7. So that is your y bar, right? And
Opo.
then we just subtracted here the half of 1, right? For the location of the centroid. So that is 5.7 minus half of 1, 0.5. Right? So what will be this, Baldos?
5.2 po. Squared.
5.2
0.2
inches. All right. Anyway, the area for area 3 is 12 times 1 and the distance D is 5.2 squared. Class, please input this in your calculator.
855.3 inches raised to 4 po.
855? Is this
Opo.
correct? 0.3? Is this
Opo.
also the answer of others? Are you getting the same answer? No more decimal places here? Okay. Anyway, 6 inches to the 4th. All right. Are you sure? Okay. So this is already your I sub x sub o, class. You still have here I sub y sub o, class. You still have to determine the moment of inertia with respect to the y centroidal axis. But I think for y centroidal axis, this will be much easier, no, as compared to your x centroidal axis, x centroidal moment of inertia. Because for y centroidal axis, I think you don't need to apply transfer term anymore, because as you can see, the centroid of all the areas here coincides with the reference y-axis, right? So that for these 3 areas, they will just be all hb cube over 12, right? No need to add a transfer term. Class, do you get what I'm saying? So kasi hindi ko na siguro pakita yon so that we can proceed, no? So for the y centroidal moment of inertia, no need to include the transfer term, no, but here, no, I still showed the transfer terms here, but as you can see, the distance, they will just be 0. So it will just be 0, no? The whole transfer term. So these are all just the centroidal moment of inertia of each area, which is hb cube over 12. All right. So class, do you follow? I mean, no need naman na yun ipakita, no? Okay na to, yung moment of inertia with respect to y centroidal axis. Ito na yon, no? Nakalagay naman na dito yung formula, yung solution. Okay, so that we can na lang proceed. Okay ka na?